For number one here, payments are continuous at 8k plus tk. And the important thing here is that they're continuous and they relate to t. So the fact that there is a t there means it's literally changing all the time. So we can just simplify this. K is a constant, so 8 plus t. So this is the formula over the 10 years for how the payment varies continuously. Interest is also dependent on t. We've got our force of interest as it relates to t of 1 over 8 plus t. Because both the payment and the interest are in terms of time, we know this is sort of going to be an integral within an integral. So it's going to be from time, it's for 10 years, so from time 0 to 10 of the payment structure, so k into 8 plus t. And then it'll be e, because we're compounding continuously at the force of interest, of 1 over 8 plus t dt. Now, normally we would go from 0 to t here. I'm actually going to say it's from t to time 10. And the reason for that is we want to accumulate any of these payments that happen at any time 10, and we want to accumulate any time t, and we want to accumulate it or roll that payment forward to time 10. So remember that the limits on the exponent of e mean how far are you accumulating it, and we want to accumulate from any time t all the way to time 10, so we're at the end because it's a future value question. So that's kind of what the solution does here. It's the integral from 0 to 10 of k into 8 plus t, and this will become e to the ln of 8 plus t from t to 10. So sub in 10, you'll get 18 minus 8 plus t, so this will just end up being 18 over 8 plus t. Remember, when we subtract logarithms, we divide the term, so that's why it's 8 plus 10 over 8 plus t. So that can go right back in the integral, 18 over 8 plus t dt. And then what happens is we just cancel our 8 plus t bracket, so it ends up being the integral from 0 to 10 of 18k dt. There's no t there, so it'll just be 18kt. 18kt from 0 to 10, which means it's 180k. We are told that 180k, the accumulated value, gets to 220,000, so k is going to equal 111.11. So a couple things to recognize. One, that the payment is continuous with respect to t, and the force of interest is continuous with respect to t, so we knew it was going to be the double integral. The tricky part about this question was setting this integral from t to 10, because it's relating, it's saying, what do you want to do with each payment that comes through? You want to accumulate it all the way from when it happens, which is at any given time t, to time 10, and that's how you do that, rolling that forward.